Hi, we're going to take a look at solving logarithmic equations using the one-to-one property. We're going to start with a review of how to use the one-to-one property to solve equations. So if we have the bases of 25 and 1/25th, 1/125th, we have to find a common base. So to find a common base, we compare our two denominators and we realize that 25 raised to an exponent is not going to equal 125. So we have to find a number smaller than both. However, we know that 5 squared is equal to 25 and it's being multiplied by the 10x plus 8 in the exponent, and 5 to the negative third power is equivalent to 1 over 125, and that's being multiplied by 4 minus 2x in the original exponent. Now that the bases are the same, we can write our equation to solve for the exponents, the variable in the exponent. So we have 2 times 10x plus 8 is equal to negative 3 times 4 minus 2x. Now we can distribute the 2 to get 20x plus 16 is equal to negative 12 plus 6x. Combine the x's, so I'm going to subtract 6x to get 14x. I'm going to subtract the 16 to get negative 28. And when you divide by x, you get negative 2. And the reason that we can have negatives and positive numbers for x in exponential equations is because the domain is all real numbers. There's no restriction on what can be in the exponent. So that's why you can have a negative exponent, you can have a positive exponent, you can have fractions in the exponent. It's all fine. However, when we take a look at logarithms, one-to-one property, we still have the rule that the base cannot equal 1. X and y are both positive numbers. Then, if we have log base b of x is equal to log base b of y, it's true if and only if x is equal to y. The other thing to note is that the bases have to also be written to be the same for us to assume that x is equal to y. The domain has to be positive, so x has to be greater than 0. And then let's take a look at how we solve some of these. We have 2 examples. Notice that log base 8 is the same for both logs, so then I can set 3x minus 8 equal to x plus 4. And I can go ahead and finish solving for x by subtracting x to get 2x minus 8 is equal to 4. And then I can add the 8 to get 2x is equal to 12. And I can divide by 2 to get x equals 6. However, we have to be mindful because whatever we have in parentheses cannot be a negative number, because this represents the answer to an exponential equation, which if I raise a base to any exponent, the answer is always positive. So we have to make sure that whatever comes after the log base is always a positive number and is greater than 0. So what we do is we take that x plus 4 and we set it greater than 0 to make sure that we find the value that would make this expression positive. So if we subtract 4, we find that x has to be greater than 4. Because if I have a number less than negative 4, that's where we start getting negative values. We can do the same thing for the other side. 3x minus 8 is greater than 0. We add the 8, divide by 3, and that's going to be 2 point something. However, this number is smaller, so we have to go by this. And we compare 6 to the greater than negative 4, and 6 is greater than negative 4. So far that's an option. And then we can just plug it back in to make sure that it is accurate. So we have 3 times 6 minus 8, and we compare to see if it's equal to log base 8 of 6 plus 4. So on this side we have 18 minus 8, and that will get us 10. So log base 8 of 10 is equal to log base 8 of 10 on both sides. So we do know that x can equal 6 for our solution. So I wrote those in a solution set. So the distinction between logs and exponential equations is that you have to solve for the domain. Solve for domain by setting whatever is in parentheses, which is after log base b greater than 0. Okay? So whatever's here is what we set greater than 0. So let's take a look at the next one. We have the same log base 6, so that's good. So now we can set 2x minus 7 is equal to 3x minus 9. We can solve for x, subtract the 2x to get x. We can add the 9 to get 2, so 2 is equal to x, but we have to check to make sure that falls within our domain. So I have the 2x minus 7. I set it greater than 0. So I add the 7, divide by 2. So 2x is greater than 7. And then it's 7 divided by 2, which is 3.5. And then the other one would be 3x minus 9 is greater than 0. Add the 9, divide by 3, and we get x has to be greater than 3. So this one was 3.5. This one is 3, so this is a smaller value. So we have to compare our answer here and see if it falls within this domain. Because 2 is less than 3, then that means this cannot be a solution. So our answer then is no solution. If it's out of this range, then we do not have a solution for this equation. So don't forget to double check your work. You can always plug it back into the original equation. So log base 6 of 2 times 2 minus 7 is equal to log base 6 of 3 times 2 minus 9. 2 times 2 is 4 minus 7 is negative 3. And we get log base 6 of 6 minus 9 is negative 3. So if you look right here, you can't take a log of a negative value. So if you plug it in and you get a negative answer, that's another way that you know that this is not going to be a solution and your answer is going to be no solution.